Okay, so on the second page, we want to start by showing how we can tell if two functions are inverses of each other. And what this definition at the top of the page says is if f and g are functions, and f composed with g of x is the same thing as g composed with f of x is equal to x, then they're inverses. So here in our third example, we want to show that f of x and g of x, as they're given here, are inverses. So remember, f composed with g of x, I like to write it like this: f of g of x. That means we're going to plug g of x into f. So everywhere there's an x here, I'm going to plug in this whole function, g of x. So it's going to give me 2x plus 1 over 2 minus x minus 1 over x plus 1 over 2 minus x plus 1. So to simplify this, I'm going to distribute this 2 first. So 2x plus 2 over 2 minus x minus 1 over x plus 1 over 2 minus x plus 1. Now, to simplify this, I want to multiply the whole thing. Remember, to have an equivalent fraction, I need to multiply the numerator and denominator by the same thing. So I'm going to multiply by 2 minus x. And the reason I'm going to do that is when I distribute here, that cancels out the denominator. And I have 2x plus 2. And then when I multiply it here, well, we're going to multiply by -1, so we'll get minus 2 plus x. And then in the denominator, when I distribute it here, again, we get rid of this 2 minus x. So we'll have x plus 1. And then here we're distributing a 1, so plus 2 minus x. And here we see the numerator simplifies to 3x. The denominator simplifies to 3, and we just get x. Now, it wasn't enough for f composed with g of x to equal x. We also needed g composed with f of x. And just a reminder that composition isn't commutative, so they're not always necessarily equal to each other. So now we also want to show that g composed with f of x is equal to x. So that means we're doing g of f of x. Similar process. So we'll have 2x minus 1 over x plus 1 over 2 minus 2x minus 1 over x plus 1. Okay, and just like I did before, I'm going to multiply the numerator and the denominator by x plus 1. I guess not just like I did, but same idea, same concept. I want to get rid of those denominators. So when I distribute it here, the x plus 1s are going to cancel out. I'll have 2x minus 1. Then here I'll be distributing a 1, so plus x plus 1. In the denominator, when I distribute it, I'm going to get 2x plus 2 minus, and I'll need to distribute that minus, so minus 2x plus 1. So again, in the numerator, I get 3x. In the denominator, I get 3, and I just get x. So by showing that f composed with g of x, we just get out x, and g composed with f of x, we just get out x, we've shown they're inverses of each other. Okay, example 4 here, we have a table, and we're told f is even, and g is 1 to 1. And then we have a bunch of function values for f and g. And this is a really great problem because next year, if you're taking AP Calc, it won't be problems just like this, but kind of the AP tests love giving you these, not the whole function, but just tables of the function to see if you understand certain properties. So here, this first one asks for f times g of 3. Now, f times g of 3 is the same as f of 3 times g of 3. It's different than composition. And so f of 3, we'll say, okay, f of x, we go over to x equals 3, find out what the f of x value is. It's 2. So 2 times g of 3, we'll go over to g, look at 3, times 4. So here our value is 8. Okay. Here we want f of negative 2 plus g inverse of negative 3. Now here you might be saying, well, we don't even have an f of negative 2 value, but we were told that f is even. So that means f of negative 2 is equal to f of 2. You also might be saying, we don't have g inverse values. But remember, if we look at what we would get out of g, or where g we get out negative 3, the inverse would be the same as putting it in, and we'll get out 8. So g inverse of negative 3 is 8. And f of 2 we see is 5. And so here we have 13. Okay, and then here we have some composition. And so we want g inverse composed with f composed with g of 8. So this is the same thing as g inverse of f of g of 8. Okay, and we're going to start kind of inside and working our way out. So g of 8 we know is negative 3. So this is the same thing as g inverse of f of negative 3. F of negative 3, well, since we know that f is even, that's the same as f of negative 3. Sorry, f of 3, which we see is 2. So we have g inverse of 2. So there we look, okay, where do we get out 2? And here that happens to be at x equals 2 for g, so that will be 2. Okay, we've got one last function here. So it says consider the piecewise function f of x equals x squared, where x is greater than 1, and 2x minus 1, where x is less than 0. So to sketch a quick graph of f, so for this part where x is greater than or equal to 1, well, at 1 we would x squared is equal to 1. We know at 2 it's 4. It's going to quickly, it's like that parabolic shape, right? Part of a parabola. And 2x minus 1 we know is a line. It's for less than 0. So at 0 this would have an intercept at negative 1, but it's an open dot there. And then it's got a slope of 2. So one way we can go down 2 to the left 1, get this straight line. And we have the question, does f have an inverse function? And we can obviously say yes, it passes the horizontal line test. Now let's talk about the domain and range of f. So our domain here is negative infinity to 0, not including 0, and then 1 to infinity, including 1. And our range is negative infinity to negative 1, not including negative 1, and 1 to infinity. Okay. Now, we know our domains and our ranges switch. And so here, for f inverse, our domain is going to be negative infinity to negative 1, and then 1 to infinity. And our range is going to be from negative infinity to 0 and from 1 to infinity. Okay. So we know our inverse of this part is going to, we need to first find that. So let's just look, if we said y equals x squared, and we switch the x and the y, we'd have x equals y squared, and we would get y equals the square root of x. Here for x is greater than 1. Okay. And we're getting that because we're really getting it for these domain values, which came from these range values. Okay, so we can start by saying f inverse of x equals the square root of x for x greater than or equal to 1. And we can see that it's going to be something like, so at 1, it would still be a 1, right? The next value that's kind of nice is 4 would be 2, right? And we would get something like this. Okay, so then let's look at our second part. Sorry, I didn't leave a lot of room. Let's do it down here. So if we said that y equals 2x minus 1, and we swapped our x and our y, we would have x equals 2y minus 1. And solving for y, we would get x plus 1 over 2 equals y. And so we can say that f inverse of x is, I'm going to write this as 1/2 x plus 1/2 for x is less than, in this case our domain is from -1. So here, let's just, at -1, that would be 0, right? So we would get an open dot here. And then if we think of going down 1 and over 2, right? That, my slope isn't right at all, is it? It shouldn't look parallel to my other one. So, well, let's just think of a negative. So if we put in -2, we would have -1 plus 1/2. So we'd have -1/2. Okay, so we would get a line there.